So today we're going to learn about ternary ionic compounds. We will learn how to write formulas for them and name them. Okay, they're very similar to what we've been doing previously with our binary ionic compounds. Ternary ionic compounds have 3 different elements. Okay. So then this time, if there's 3 different elements, it means you're going to have like a single element on its own bonded to a polyatomic ion. Okay, so when you hear ternary ionic compounds, think polyatomic ions. And where do you find all of the names and formulas for polyatomic ions? Your naming chart. Okay, so we're going to learn how to write formulas first. I have all the steps. You don't necessarily need to write these. Okay, so these are here for you. If you're someone who you like to follow like the step-by-step directions, these are here for you. You can write them. We're going to do a handful of practice problems together where we're going to follow these steps. Okay. The technique is the same as binary compounds, where you still write the formula and charge for each ion. Okay. You still balance the charges. What technique do we use to balance the charges? Okay, crisscross. So we're still doing the crisscross rule. The only new parts are first you have to recognize if a polyatomic ion is present. So when we write formulas, you're going to be given the name. Okay, so what about the name is going to tell you there's a polyatomic ion. So if you take a look at your naming chart, okay, look at those polyatomic ions. How do most polyatomic ions end? What 3 letters do they typically end in? Ite or 8. Okay. So now if you read a name and the name ends in ite or 8, that should be an indicator that it's a polyatomic ion. Okay. So if you see ite or 8, you should think polyatomic ion chart. Okay. There are a few exceptions. Okay. So some exceptions are like hydroxide and cyanide. Okay. These still end in ides. However, another good indicator is if you're looking for hydroxide or cyanide on the periodic table and you can't find it, that should be a clue to flip the page over and see if it's a polyatomic ion. Okay. So the first thing we'll have to do is figure out, is there a polyatomic ion? We'll get used to the naming. So we're looking for ites or 8s. Okay. And then when we write formulas, most of the time you have to put parentheses around the polyatomic ion. Okay. And I'll show you what I mean by that when we do example problems. Okay, so here's our first example. It's calcium nitrate. So what about the name indicates that there's a polyatomic ion? Okay, so when I say 8, I'm talking about these last 3 letters. Okay, so everyone look at the example. Okay, so do you see how nitrate ends in ATE? Yeah. Okay, so that kind of ending, that's telling you it's a polyatomic ion, so you're going to use the naming chart. Okay, and then we're going to follow the same technique that we always have, though. So what is the symbol of calcium? Okay, what's the charge? 2 plus. Okay, it's in that second column, so it's a +2 charge. Okay, then nitrate, where do you find the formula for nitrate? Okay. You're going to find it on that naming chart. Okay, so everyone get out the naming chart, find nitrate. All right, what is the formula for nitrate?
I know 3, 1 minus.
Okay, can everybody find nitrate on their chart? Okay, make sure you're finding it. You know where to look. So nitrate is NO3 with a -1 charge. Okay, we have our charges. What's the next step?
Cross.
Okay, crisscross. Numbers only, no charges. So we end up with Ca1. And then this time it's a little different. Nitrate is its own thing. We're going to put parentheses around the nitrate. Okay, so I'm going to put parentheses. And then the 2 goes after the parentheses. Okay. And then finally, do we have to write the 1? Okay, in fact, we don't write it. So I'm just going to write CaNO3 2. Okay. So this is like the proper formula for calcium nitrate. Let me show you why we have to have parentheses. Okay. So I'm going to change the color. So if I didn't use parentheses, I'd have Ca3NO32. Does that look like NO32? Okay, so make sure when you have your polyatomics, you'd have to put the parentheses there to make it 2 nitrates rather than 32 oxygens. Okay. All right, our first one is strontium sulfate. What is the symbol for strontium? Okay. All right, so strontium is Sr2+. All right, sulfate, what 3 letters tell you it's a polyatomic ion? 8. ATE. So where do you look to find that formula?
In the back.
Okay, use your naming chart. So find sulfate.
SO4 2 minus.
Okay, do you all agree with that?
Yeah.
Okay, SO4 2 minus. So we have our charges. What's the next step? Okay, crisscross rule. So we end up with Sr2. What do we have to put around the SO4? Okay, parentheses and then the 2 on the outside. Because sulfate is a polyatomic ion, so the SO4 acts as 1 unit. Okay, so you gotta it groups it as that 1 unit. Hold on, I'm not done yet. Okay, everyone focus up here. Okay, look at the board. If you can reduce subscripts, do you have to? Okay, I'm gonna highlight the only subscripts we can touch though. So when we reduce subscripts, you can only reduce the subscripts you get from the crisscross rule. Okay, even though the 4 in SO4, does it still share a lowest common denominator between these 2's? Okay, you cannot touch this 4. The reason is, it's part of sulfate. If you change this, is it sulfate anymore? Okay, so you do have to reduce subscripts, but you cannot touch the polyatomic ion. Okay, the only subscripts you reduce are the 2 that you get from the crisscross rule. Okay, so what is this going to reduce down to? Those 2's are going to just divide by 2. So SR, SO4. Okay. All right.
So does it not need parentheses anymore?
It doesn't need parentheses anymore. So because you didn't have to add an extra subscript, you technically don't need parentheses around the SO4. When you see strontium sulfate in writing, this is the way you'll see it. In class, if you just have to put parentheses around it, because that's how you just have to do it, I wouldn't take off points for this. Okay, but if you're going to look at strontium sulfate published anywhere, it wouldn't have parentheses in this case. Okay, the next one is copper 2 sulfate. What's the symbol for copper? Okay. What's the charge? Okay. Where are you going to find the formula for sulfate? Okay, what's the formula for sulfate?
SO4 2 minus.
Okay, what's the next step? Okay, crisscross. So we get Cu2. What has to go around the SO4?
Parentheses.
Okay, parentheses. All right, are we done? What has to happen next? Okay, can we reduce the subscripts? Okay, so what's our final answer? Good. Okay, so our final answer is CuSO4. All right, next we have sodium cyanide. What's the symbol for sodium? Okay, what's the charge? Okay, +1. Cyanide, it ends in "ide." However, if you search on the periodic table, are you ever going to find it? Nope, it's a polyatomic ion. So you're going to have to find it on the back. Okay, so if you find cyanide, it's Cn with a -1 charge. What's the next step? Okay, crisscross. So you end up with Na1, Cn1. Do we have to write the ones?
No.
Okay, so what's our formula? Okay, so just NaCN. Okay, and the last one is calcium acetate. What's calcium? What's the charge for calcium? Okay, find acetate on your naming chart. Okay, everyone look at acetate. Do you see acetate?
Yes.
Okay, do you see how it is CH3COO or C2H3O2? You pick one of those. Okay. I tend to like the C2H3O2. It doesn't matter. Okay, you pick whichever one. Don't write them both though. Okay, it's or. Pick one or the other. All right, what's the next step? Okay, crisscross. So we end up with Ca1. What has to go around the acetate? Okay, parentheses. Okay, and then your superscript comes down as a subscript on the outside. Do we write the 1? Okay, we don't. I just like to show you so you can track them. Okay, so calcium acetate is Ca, parentheses, C2H3O2, close parentheses, 2. When we name ternary ionic compounds, it is pretty much exactly like binary. First, you have to recognize that there's a polyatomic ion in the formula. This time, you look at the formula. So what's going to be your indicator that it's ternary or there's a polyatomic ion? Maybe parentheses. How many elements are there going to be? Okay, so there's going to be at least 3 elements. Okay, so when we say recognize it's a polyatomic ion, it'll be 3 or more elements. And then when we name it, it's just the name of the cation goes first. Does the name of the cation ever change? Okay, so it's just the name of the cation. Then it's the name of the anion. If the anion is the polyatomic ion, the name doesn't change. It's exactly how you find it on your naming chart. So here's our example. NaC2H3O2. How do you count the number of elements in this formula? Okay, so you're counting capital letters. How many capital letters do you see? 4, right? 1, 2, 3, 4. Okay, so this is your indicator. This is how you know there's a polyatomic ion. Are there more than 3 elements? Okay, so then you know one of them has to be a polyatomic ion. Okay. Most of the time, the first element is the single element. Okay, so Na, it's going to be on its own. So then that means everything else is the polyatomic ion. So then you would look at your naming chart, and you're going to look for C2H3O2. Do you find that? Do you find that formula on there? Very top right. Okay, so then when you name it, Na is sodium. And if you look at C2H3O2, what's the name? Acetate, okay? So it's just called sodium acetate, okay? You don't change the ending if it's a polyatomic ion. Okay, so for these 2 examples, we're just going to practice naming them. The first one is CuClO2, 2. Okay. So what's Cu? Copper. What's the question we ask ourselves every time we name ionics? Is copper a transition metal? Is it? Yes. So what does that mean? Okay, so yes, we have to put the charge in parentheses. Okay, and we're going to figure out the charge the same way that we did with binaries. So find ClO2 on your polyatomic ion chart. Okay, what is the charge of ClO2? Okay, so it's a -1 charge. How many of these ions are there? Okay, 2. So what's -1 times 2? Okay, so the overall negative charge is -2. So what does the positive charge have to be? +2. Okay. All right, so what's the charge of copper? Okay, so it's copper 2. And then what's the name of ClO2? Okay. Is there a difference between chlorite and chlorate? Okay, so just make sure you're paying attention and you're actually getting those last 3 letters correct. So it should be copper 2 chlorite. Okay, that's as hard as it gets, like with the transition metal and the polyatomic ion. So any questions on that one? Okay, let's look at Na3PO4. Okay. How do you know one of these has to be a polyatomic ion?
There's 3.
Okay, there's at least 3 elements. Okay. So then we look at Na. What's the name of Na? Sodium. What question do you ask yourself? Okay, is sodium a transition metal? No. So do you have to write the charge? Okay, so it's just sodium. All right, which leaves PO4. What's PO4? Phosphate. Okay, do we change the end of phosphate? Okay, nope. For polyatomic ions, however it's named on the sheet is the name that you use. No changing it. So Na3PO4 is sodium phosphate.